Alright guys, so this video we'll be going through the quadratic roots. Alright, so from before we did the linear repeated. So we'll do the quadratic. So the quadratic is basically when you cannot factorize it into linear, you'll just be left with the quadratic, right? So that is basically it's fully factorized. It can't go any further. That is the full you could get. Can't get any fuller than that. Alright. So So when in the denominators of the form ax squared plus bx plus c, don't get into the habit. It don't always have to be a, b, and c. The b and c could be zero. A quadratic, once the highest power of x is 2, is by default a quadratic. So 2x squares are quadratic, x squares are quadratic, x squared plus 1 is a quadratic, but x plus 1 is not a quadratic. Yeah, so just remember that. Just have this in itself is a quadratic. Yeah, so don't get into the habit of once it not like a full way to give it a, b, and c. Is not quadratic root. Alright, once it has power of x is 2, it's a quadratic root. Alright, so first example, we have this one here. So this is the denominator fully factorized, meaning it probably could not have gone any further. So since this is a quadratic roots, so a little change now. So when you end the quadratic roots, when you notice a quadratic root, the numerator is not just a alone, is ax plus b. So for the linear, the numerator is just a constant, and for a quadratic, you get a ax plus b. And actually, if you wanted to continue the pattern, the cubic will have been a quadratic, so it'll be ax squared plus bx plus c, and something to the fourth will have been the cubic. So the pattern is the linear is a constant, the quadratic is a linear, and the cubic is a quadratic. There's a little pattern that going on. Yeah, so let's remember that. So for linear is a constant like a quadratic would be ax plus b, and a cubic, which is our rare thing to see, it will be ax squared plus bx plus c in the numerator. Yeah, so let's be careful with that. There's a quadratic, and a quadratic, the numerator, when you're writing it in the partial fraction form, is ax plus b. Now we'll continue on if you have more quadratics. So like example 2, with this part here. So if I'm doing this one here now, don't forget what the numerator have. Right in this denominator, you have a quadratic here, and you have a quadratic here. Yeah? So that's be ax plus b over the first quadratic root plus, and then ab, so it'll be cx plus d over the second quadratic root. Yeah? And that's how you do the quadratic, right? So as I said before, this is the general form, or the partial factor form of a quadratic root. Yeah, so just remember that it's different for the linear. Yeah, so that's all the stuff. Remember these steps. Yeah, make sure you know these by the back of your hand. All right. So let's try a question. So as before, so far we did the linear. All right, so we did the linear repeated. Now we're gonna do the quadratic. All right. So the same steps. Um, so the numerator, that we'll care about it for now. The denominator, looking at it, it's fully factorized. Alright, so assuming it is fully factorized, meaning that I can't go any further than these here. You have to write it in the partial fraction form, right? So that's continuing from that. Kind of feeling to write over all that. So yeah, put ax plus b on the first one, and it'll be plus cx plus d on the second. Step 1 to complete. Step 2.5. Remember, just multiply both sides by this. Yeah. So on the left hand side, I will cancel. Alright, so when you multiply this will cancel, so you end up with ax plus b by the other one plus cx plus t by this one. Yeah, how I know we think of it to know what you multiply this by. When you multiply both sides, it basically everything, every other denominator on this side except the one at under. So ax plus b by this. If it had more, it would be ax plus b by this by the other denominators except the one that it over. And with the same idea for this one. Every other denominator except the one at under. Yeah? Alright, so we have this here now. So as I said, you have multiple ways that you could do this. Alright, so let's see. The best way to do this one probably might be a mixture of the two of them, but in this case here, if I is 0, you currently plug in one value of x to eliminate something probably. So I think in this one here, I'll just use eliminate the expansion and the equating coefficients method, right? So 2x plus 1 will just stay like that. And we just have to expand this piece here. So this will take a little bit. So let's see. So we have, that'll be this by that. So it'll be 2ax cubed just by this. That'll be ax squared. This by this will be plus 2bx squared. And this by that will be plus x. Yeah, and then well, this is the same thing, or the same idea. So cx by this will be plus cx cubed. Cx by that will be plus cx. And then this by this will be plus dx squared. And d by 1 will just be plus d. Yeah, next up we have group coefficients. Okay, add the group before you equate. So all the x cubes, you can just group it. So x cube, what we have an x cube. We have 2a cross over where we have c, we have c. I think that's all the x cubes we have. Then x squared now. What we have with x squared, we have a cross out. We have plus 2b cross out. We have d and cross it out. X now. So on the x side now we have b and we have c. Cross out, cross out, and then we just left with d as the remaining constant, right? So now we continue now, so we have to equate. So remember I told you, right, anything that is not there is 0, because technically you're looking at x cubed here, we don't have x cubed, but I could write this left hand side as this. So I could say 0 x cubed plus 0 x squared plus 2x plus 1. Yeah, if this easier for you to see, you can write it in like that. Yeah, you're starting off with the same thing because 0 by anything is 0, right? And I would just equal to x cubed to a plus c plus a x squared a plus 2b plus d plus a x by a b plus c plus b. Yeah, so now we could finally equate coefficients, right? So we state equating coefficients of x. So we have 0 x cubed. So x cubed here will equal to this here. So it'll be x cubed to a plus c. So we have 0 x squared. We equate it for the x squared term, so it'll be x squared a plus 2b plus d. And then we have the x term, so it'll be 2x x b plus c and then the last one, D. So 1 would just equal to D, or D is equal to 1. Yeah, so now we can rewrite these equations because we're trying to form equations to solve simultaneously, right? So for this one here, cancel the x cubed, so it'll be 2a plus c is equal to 0. For that one, for this one, it will be a plus 2b plus d, and that is equal to 0. For that 2, this one, b plus c will equal to 2 after you cancel the x. And the last one, d is equal to 1 for that 4. Yeah, so now what we could do, we could plug d into the equations on top and solve. So we could say this was steady state. All right, this one here. So you plug in D4 into this one here. So you end up with A plus 2B plus 1 is equal to 0. Yeah. And then AB plus C is equal to 2 will stay. So 1, 2, 3, 4, 7, 6, and it's 3, 5. Just keeping track of what we're doing, right? So here we have 3 equations that we could solve for. So we could actually make more substitutions to make less equations that we had to solve for, right? So what we could do now, a little bit of manipulation, we could actually solve one equation for one letter and then plug that letter back into the other equation, right? So we could say we could plug this into here. But before, we have to transpose. So it makes C the subject, right? So if we're making C would just equal to 2 minus B, right? After the character cross. So we could plug this into here, right? So rewriting the equations over now. So it'll be 2a and C is 2 minus B. So it'll be plus 2 minus B and that will equal to 0. Yeah, that was this here. And then the other equation will stay as A plus 2B and that will equal to minus 1. Yeah, so we could rewrite and then we obviously have so we have 2 equations now, right? So we get less and less equations. We need 2 letters. Once you have 2 letters, we could just plug into the original ones and solve for the other letters. Yeah. So let's rewrite this on an easier way to look at. So this piece here will be 2a minus b, and if you carry across the 2, and then you end up here, and then you have a plus 2b is equal to minus 1. Yeah, and then obviously if you all have a calculator that could do the cubic when it's simultaneous, you could have plugged in these equations, yeah, and just solve for them. But luckily I don't have that, or these, yeah. But if you don't have it, you just have to go through these steps here, right? Or you could have up to this part, you could even plug it in your calculator. So because I don't have that, I'll have to solve it. So I'm showing you only long. Alright, so to solve this now, we could do the same thing, plug this into this and solve for the letter, right? So let's see. So we can make A the subject of the formula. So A negative 1 minus 2B, and you plug it into the first one. So A, so it'll be 2 minus 1 minus 2B minus B is minus 2. So expand then minus 2 minus 4B minus B is equal to a minus 2. Simplifying, so you have minus 5B minus 2 equal to minus 2. So you end up with minus 5B, characters the minus 2. You get plus 2, so it'll be 0. So B will equal to 0. Yeah. So since we have b now, we can actually get everything else that we wanted to. Yeah. So we have b, we're looking at these equations here now. So we have b as 0, so we could plug it into. So we could say substituting e equal to 0 into 3. So 0 plus c is equal to 2. So c is equal to 2. Yeah, what else? So c is equal to 2. Now we could solve for e, right? So we could say substituting c is equal to 2 into 1. So 2a plus 2 is equal to 0. So 2a is equal to minus 2. So a is equal to minus 1. So we have a, we have b, we have c, we have d. So now finally we can write it back in its partial fraction form, right? So we had, let's change the color. So we had 2x plus 1 all on x squared plus 1 and like 2x squared plus 1x, I believe. Yeah, and that'll be to, let's see, a is minus 1, x plus b, which is 0. So that'll be that part there, divided by the first root, which was x squared plus 1. Then we have ax plus b and cx. So c plus 2, so it'll be plus 2x and d plus 1. Yeah, that's plugging it back into the size of 2x squared plus 1. Yeah, and eyes are there in the partial fraction form. So the quadratics are a little more like mathematics based. All right. But as you continue and you practice it, you'll just get accustomed to it. So just to let at this point here, some people's calculators, you could actually solve cubics simultaneously. So you could have just plugged in these if you know how to do it into your calculator and calculate what ABC is. I already know what D is. All right. Or if your calculator can't do 3 and it can do 2 equations, you can do the same thing I did, solve for one and plug it into the other one, and you just end up with 2 equations. And then you can plug it into your calculator, solve it simultaneously, which you'll get A and B. And once you have A and B, you just have to solve for C. Just plug in one into either one of the equations, and you get it. They already have D. Yeah. Um, that's the quadratic root. Yeah. So next is the quadratic repeated, and that'll be the end of the series. All right, later.